The next example problem is next permutation problem. So given the permutation of a multi-set of numbers, so in this particular problem, we could have the same number appearing multiple times. So given these numbers and the permutation of them, we are asked to compute the next permutation, which is the lexicographical, based on that lexicographical order. Another way to look at it is if we view each of the number as a digit, then we want the next bigger number that can be formed using these digits. So for example, if 1, 2, 3, then the next one should be 1, 3, 2. And if we are already at the biggest number, then the next one is the smallest. So the next of 3 to 1 is 1, 2, 3. So this last example is one where we have duplicate numbers. So 115, the next one will be 151. So yeah, again, I encourage you to pause the video and think about how you would solve this problem. So the way, I think in general, the better method to solve a hard problem is to make it more concrete. So, and to simplify it. So if a problem is too hard, try to solve a sub-problem, fixing something, and then have a simpler version, solve that first. And or if we don't have an idea of how to solve a problem in general, let's look at some concrete instances. So let's look at these instances. What are the next permutation for each of these? So 1, 2, 5, 4, 3, 6. Well, the next one, it looks like the next one should be 1, 2, 5, 4, 6, 3, right? So, so then we simply switch the last two. Then that will work. But look at the next string, 1, 3, 4, 6, 4, 5, 2. If we switch the last two, then we get something that's smaller. It's not the next, it's the previous. So we can switch the last two when the last one is bigger than the previous one, because then switching will give us the bigger one, give us the next one. If the last one is smaller than the previous one, then we need to keep going back. Now in this case, 4, 5, 2, so the next bigger one, because 4 is less than 5, so then we can use the 5 here, and then we want use the 2 and 4, place 2 and 4 in the last two position so that it's smallest. So then it will be 5, 2, 4. So this will be 1, 3, 6, 5, 2, 4. Now look at this. So 1 is less than 3, 3 is less than 5, 5 less than 6. So we can't really do anything. We can't get the next string by just looking at this tail end of this this permutation, because this keep decreasing, and whatever we do, we are only going to get something smaller. So we have to keep going forward until we see something that's smaller than the one we just saw. So here we look at 4. We said, now there is some way to do it. Now, which one should we place here? To get the next biggest, we need to find something that's bigger than 4, but we want to find the smallest among the tail end that's bigger than 4. So then we want 5. And if we have 5 here, then we want the rest of them to be from smallest to biggest. So basically this will be so okay. So this will be 2, 5, 1, 3, 4, 6. So in a sense, we were going back, and then we find something that's smaller, and then we will swap this this guy with the smallest number that's bigger than it, and then we just need to sort the rest. So that will be one way to do it. Now let's look at the last one. So the last one is we are already at the biggest one, so the next one is the smallest. But we can also apply this same logic. We'll keep going back, but we never see anyone that's smaller. So, and we are done. So there is nothing for us to swap. So we just need to sort. from smallest to biggest. And that's essentially what this code does. So I won't spend time actually going into them. You can, it's following that logic. You can understand yourself. The only thing is I think I wrote a helper function for reverse part of an array. So this function will reverse starting from this index, ending at this index. It will reverse the element in the array. And this is C++ code. And in fact, you can also do this by simply calling next permutation, because this is a part of the STL in C++. So